In this video, we're going to evaluate the integral of x multiplied by x plus 5 to the fourth power. Now, at least a couple of ways to do it. One way would be to take x plus 5 to the fourth power and expand it. Just multiply it out, combine your terms, and then multiply by x. And you'll have a polynomial of degree 4 when you expand this one to the fourth power. And then multiplied by x, you get 1 to the fifth power. And you can evaluate term by term. Can be done that way, but you don't want to do it that way. Second method that I would prefer, because even though the exponent is not that large, what happens if this is in the 10th power? Then it'd be real messy. So let's start by letting u equal to x plus 5. See if we can get a u substitution here to work. Let u equal to x plus 5. That'll be this expression right here in the parentheses. Then du would be the derivative of x plus 5, which is 1. So this will give me a dx here. So we got a representation for the x plus 5. That'll be u. The dx over here would be du. Nope, we can't have any variables like an x. Just a variable u now. So let's take this 5 over to this side. Get a minus 5 on the left side. And on the right side we get x. So now the x can be replaced by u minus 5. So the x is replaced by u minus 5. X plus 5 is u, and that's taken to the fourth power. Dx replaced by du. And now we have a product here that we can write it in polynomial form in terms of u. So multiply by u to the fourth here, we get u to the fifth minus 5. U to the fourth. Multiplying that out. And this is still going to be a du here. And we just integrate with respect to u here. Add 1 to the 5, we get 6 here. Divide by 6. Add 5 here. Or add 1 rather to that 4, you get 5, and then divide. This will stay negative 1. U to the fifth power. Plus the constant of integration. Now we go back to the original variable, which was x. So you have a u with the x plus 5. So it'll be x plus 5 here to the 6th power. It's over 6 minus u to the 5th, and u is x plus 5 to the 5th power here, and then plus 6, or plus the constant of integration, which is c. And this is your answer here. You can leave it in this format, or you can do some factoring here and rewrite it in a different or simpler form. In other words, you got an x plus 5 to the 5th here, and x plus 5 to the 6th here. We could take the x plus 5 out. Let's just do it this way. That's to the 5th here. And then what was left in here. So we took an x plus 5 to the 5th out. That leaves me with x plus 5 to the first power. And that's still over 6. X plus 5 to the 5th times x plus 5 to the first power is still x plus 5 to the 6th. And then minus over here, taking this x plus 5 to the 5th, there's be a minus 1 here, plus the constant of integration. And then we can simplify the expression in the parentheses. You'll still have the x plus 5 here, x plus 5 to the 5th. Then this part we can rewrite that x plus 5 over 6 and the minus 1 over 6. Let's write the minus 1 as minus 6 over 6. Now we have the same denominator here. So we have x plus 5 minus 6. So this would be an x minus 1 over 6. Parenthesis here plus the constant of integration. So again, no issue leaving it like that. But just again to let you know that sometimes a textbook will simplify the answer a little bit more. So you might see this answer written this way. X plus 5 to the 5th times x minus 1 over 6 plus the constant of integration. Thanks for watching. We'll see you next time.